Today we jumped into the exciting world of fractions. So you guys started off today by thinking about money and what fractions each of these amounts of coins would be of a euro, and you did a great job. You knew that 60 cents out of 100 cents that make a euro is the same as 3/5 of a euro, and 5 10-cent coins is a half a euro, and 2 5-cent coins would be a tenth of a euro. So we talked about what equal fractions mean and what fractions in lowest terms means. Then we worked with some fraction bars, and you guys found the red bar that had 4 parts shaded out of 6. And it's a model for 4, 6, and we just talked about reviewing some terminology. 4 is called the numerator, and the 6 is called the denominator. And you have to understand that the denominator means that the whole bar has been broken into 6 equal-sized pieces. 4 of them were the parts of the 6 that were shaded. So think of this being a Snickers candy bar. If I broke the candy bar into 6 equal parts and you ate 4 of them, that's the amount of the bar that you ate, and it's the parts out of a whole. So you ate 4 parts out of the whole 6 parts of the bar. Okay, then we looked at fraction bars that have all of the parts shaded, and you guys all understood that these are all different ways to name the whole bar being shaded. And this is a division problem. 4 divided by 4 is 1 whole, because 4/4 is the entire bar. And you found the 6/6 and the 12/12 and the 2/2 and the 3/3 and the 5/5, and all of those had the entire whole bar shaded. And then we looked about the bars that have nothing shaded, and they all showed 0 parts of the bar shaded. Here they are all right here. And those are all equal to 0, and 0 divided by 2 is 0, and 0 divided by 5 is 0, and 0 divided by 6 is 0, etc. All right, then we started looking at some bars that have different numbers, yet they have the same amount shaded. So just like I can use different coins to show a euro, I could have 5 20-cent coins to show a euro, or 2 50-cent coins to show a euro, and yet they're both the same amount of money. 1/4 is the same amount as 3/12. And the cool thing about the bars is it just shows you that they have the same shaded amount. The 12s are just smaller pieces. So those 3, when I group each of those 3 parts together, I have 1 bigger part shaded out of 4 bigger parts. But we don't always want to be making fraction bars. It's not very efficient. So we looked at what divide pattern. When I circle each group of 3, it's like dividing by 3. And in the whole bar, I circle each group of 3, it's like dividing by 3. And that's the fast way to get to the fewest parts that are the biggest size pieces that are equal to the fraction in lowest terms. And that was 1/4. And then you guys just worked with some different fraction bars, and you found the parts that had fewer pieces. So we found the 9/12 bar, and you guys all found the equal sized bar that had the same shading, and that was 3/4. And then we talked about the division patterns for that. And then you pulled out some bars that were the same sizes, and we talked about the multiply pattern and the divide pattern to get to lowest terms, or to get to a bigger denominator so that we could later on add or subtract fractions. And then we played around with bars and described bars that had more parts but the same amount shaded. So I had you just imagine these bars. So we could have 3 parts out of 12, 2 parts out of 8, 5 parts out of 20, 4 parts out of 16. And then we just looked at a cool pattern. Because 1 times 4 is 4, all of these have that same pattern. 3 times 4 is 12, 2 times 4 is 8, 5 times 4 is 20, 4 times 4 is 16. So another pattern to 1/4 is that in every fraction that's equal to a fourth, the numerator times 4 gives you the denominator. And that's what 1/4 means. Okay, then 3/4, I had you describe different fractions that have the 3/4 bar broken into smaller pieces, but the same amount shaded, and all of these were equal to that same amount shaded. And then we just threw in the fact that when we have a number out of 100, that also can be written as 75%, because percent means out of 100. And that tells us that 3/4 is the same amount as 75%. And then I had you imagine the 2/3 bar with more parts but the same amount of shading, and you guys came up with, if we broke them each into 4 parts, they'd be equal to 8/12. If we broke them each into 5 parts, it's 10/15. If we broke them each into 3 parts, it's 6/9. And then we looked at number lines, because it's the same idea but a different model. So you guys took turns coming up to the smartboard, and first you broke the distance from 0 to 1 into 3 equal intervals, each one being a third. and I had someone come up and show us 2/3. Then somebody else came up and broke 0 and 1's distance into 6 equal intervals, and they found the same equal fraction in 6, and then the same thing with 9 intervals, and all of these fractions are the same distance from 0 to 1. So 2/3, 4/6, and 6/9 are all equivalent fractions. And we did the same thing with fourths on a number line. And then I had you make your own fraction bar for 2/5, and so you guys broke a bar into 5 equal parts. You can see with the blue lines, and then we shaded 2 of them, and then you had to divide the bar into equal parts to show 6/15. So most of you did a great job with this. You just broke each fifth into 3 equal parts, and now we can see that 6/15 is the same amount shaded as 2/5. And then we compared fractions. How do you know which one's bigger? And Brody had a really good way of thinking about this. He said he knew 4/5 was bigger because if you picture a fraction bar with 4/5, the gap to having the whole thing shaded 1/5 is smaller than the gap of a third. And that's excellent reasoning, which means that 4/5, the shaded part, is bigger. And somebody else said, well, we can rewrite them with the same denominator. So we break them all into the same size pieces. And the number pattern with that is 3 times 5 is 15. So we would have 2 times 5, or 10 shaded parts. So 2/3 is equal to 10/15. And 4/5 is equal to 12/15. So that means that 2/3 is less than 4/5. And then I said, is 6/11 equal to 5/9? And you guys discussed that in your group, and I said, how can you tell? And most of you predicted correctly, but they're very close together. They're only 1/99 apart. So if we do the mathematics to prove it, 6/11 is only 54 parts shaded out of 99, and 5/9 is 55 parts shaded out of 99. So 5/9 is bigger. And then we talked about, whoa, what about when they're negative fractions? So remember, they're always the opposite of their positive side of a number line. And some of you have an easier time by first of all finding if they were positive, which is bigger, but because they're negative, the bigger one is actually the smaller one. Because as we get closer to 0 on the number line, the fractions get bigger. So if we pretend that these are positive fractions, 6/7 is equal to 30/35. So it's bigger than 28/35. But we're on the opposite side of 0, so actually 28/35 as a negative number is the bigger fraction because it's going to be closer to 0. And then we did some without the bars and without even finding the common denominator, just using reasoning, and a lot of you had some great reasons. You were going to compare to halves. We know that 3 out of 6 is a half, and this is bigger than 3, so 4/6 is larger. And comparing to halves, this is less than a half, and this is bigger than a half, so 2/3 is definitely larger. And the same with these. 5/6 is closer to 6/6 than 7/12 is. This is closer to a half, so we know 5/6 is bigger. We just did a check to make sure by finding out how many 12ths it would be. And we knew that 3/4 is closer to 1/2 than 2/3. And then we quickly reviewed factors, and I'll show you the reason in just a minute, just to make sure everybody remembers that factors are just numbers that multiply to equal 12. And if you think of rectangles, the dimensions of all the possible rectangles with an area of 12 square units is a really easy way to find all the factors of 12. So I can have a 1 by 12 rectangle, 2 by 6 rectangle, and a 3 by 4 rectangle. And then we looked at the factors of 18. And the rectangles I can make that have an area of 18 square units are a 1 by 18, a 2 by 9, a 3 by 6. And now the purpose for this is if I look at all the factor pairs for 12 and the factor pairs for 18, that's important when I want to efficiently, quickly simplify 12/18 to lowest terms. So I look at all of the factors that they have that are the same. Those are called common factors. And I want to find the biggest common factor because that will get me to lowest terms the fastest way. And the biggest common factor they share is 6. So that means that I would circle each 6 parts that are shaded, and I'd have 2 bigger parts. And each of the 6 parts in the whole bar gives me 3 parts. So 12/18 in lowest terms, the biggest parts and the smallest numbers in the fraction would equal 2/3. Okay, then I taught you how to play FracJack. We'll play it next class. And you have just a little bit of homework practice. You're just doing part of this lesson today, so just numbers 1 through 10 for everybody. Have a read through of your new projects for Chapter 3. You're going to have to do some research. So on the first choice, you've got to actually go to a grocery store and find some prices and actually interview somebody that works at the grocery store. The second one, you have to survey 25 people. And the fifth one, for those who love to draw, you're going to have to make a drawing or a painting using the golden ratio. So I just would like you to read over your 3 choices of your projects because you're going to have to start them earlier this unit. And that's it. Have a great weekend.